Hi, this is Mrs. Carnes, and this video is going to be a review of inequalities and their graphs. You probably are very familiar with a lot of this information, but the reason that it's important to know about inequalities and how to graph them is because there's a lot of real-world examples out there that can be represented using inequalities. The three that you see here we will answer at the end of this video. You are probably familiar with the inequality symbols, but a lot of students forget what each symbol means. So as a refresher, let's take a look at the four symbols. This symbol here is read as is greater than. So the symbol means that the number is greater than something. The symbol, when you put the line underneath it, is read as is greater than or equal to. You're probably familiar that the line underneath an inequality is referred to as the equal to part. We also know that we have is less than. This symbol is read as is less than, and then of course when you put the line underneath it, it's read is less than or equal to. It's really important that you remember the sign and what it actually represents, because that's how you're going to know which way to graph when you come to a number line. Let's take a look at a quick example here. If I use the example here, x is greater than 2, then I have read it exactly the right way. X is greater than 2, and that's how the symbol is read. We could come up with lots of examples that would satisfy that equation, and we'll talk more about that later on. We could also write it as x is greater than or equal to 2. And so again, you can see that in this case, 2 would be a solution because it could equal it, but it also could be greater than. Similarly, with the less than, I could say s is less than 1/2. Or I could say s is less than or equal to 1/2. All of these are examples of how you would use these symbols and read them when you came across them. One important thing I want to remind you of is that, remember, you can flip these around. The variable does not have to come first. So if we go back up and we look at our first example, x is greater than 2, I could write this as 2 is less than x. These two statements are completely equivalent to each other. X is greater than 2 or 2 is less than x. They mean the exact same thing. So please don't get confused there. Remember that. Now, when we talk about graphing inequalities, we have to remember what the symbols mean when we talk about them on a graph. And so if you have a greater than symbol or a less than symbol, then we always use an open circle on our graph. And if you have the greater than or equal to or the less than or equal to symbol, then you always use a closed circle to represent the equal to part on that graph. So let's take a look at the example. If we started off with x was greater than 2, that's what we talked about on the last slide. If x is greater than 2, then you would use an open circle on the 2. And so I would come to my graph, I would have an open circle on the 2, and then I would have to decide which way to draw the arrow. Do I go bigger than 2 or less than 2? And when you take a look at your statement again, it said x is greater than. So I need to go to the greater than 2 side, which would be going to the right. Anything that would be greater than it. So that's one way that you can graph that equation. That's also a reason why it's very important to know how to read these inequality symbols so that you know which way to draw the arrows when you go to graph them. Let's take a look at an inequality example that uses the less than or equal to. So if we were going to come to this example, s is less than or equal to 1/2. So again, I would have to find 1/2 on my number line. We know that that's in between the 0 and the 1. And in this case, I would use a closed circle because it has the equal part on it. So I would make a closed circle at 1/2. And then I'd have to find which direction to go. I come back and I look at my inequality and it says s is less than or equal to. So the less than part means that I'm going to have to travel to the left. And so that's how you would graph those inequalities. So let's take a look then at our real examples. This first example says the school band makes more than 12 appearances each year. More than is the key word here. More than means that we're going to be using the greater than symbol. And so we're going to let A be the appearances that the school band makes, and we know that it has to be more than or greater than 12. We know, though, that it can't be equal to 12 because it doesn't say that. So we would have an open circle on 12, and we would know that our arrow goes to the right to be greater than that. Let's take a look at the next one. It says you must be at least 16 years old to get your driver's license. Now you have to think about what the word at least means. When it says at least 16, it means you can be 16 or you can be older, but 16 is the least amount of years you can be. So it's the smallest that you can be. So if we let y equal the years that you are, you must be at least 16 years old. It means that you must be greater than, but you could also be equal to 16. So this would be read as y is greater than or equal to 16. Again, that would be a closed circle on the 16 going to the right to be greater than. And the last one uses the word at most. A bus can seat at most 48 students. The word at most means the opposite of at least. At most means 48 students, but no more. You can have 48 students on the bus, but there are no more. 48 is the maximum amount. So if we let S be the number of students that are going to sit on the bus, we know that that value has to be less than 48, but it could also be equal to 48. And so the equation, or I'm sorry, the inequality that we come up with is S is less than or equal to 48. Again, that would be a closed circle on 48 on your number line, and this time it would go to the left, indicating less than that. So now that you've seen that you can use inequalities to represent some real-world examples, and you should have a refresher course on what inequalities stand for, we're next going to be able to solve inequalities that you can create using real-world problems.